All right, everyone, I think we're ready to begin with our afternoon session here at the 6th edition of the International Flight Safety Seminar for the CAAs and operators. Well, we're going to begin in the afternoon session with the second session entitled New Technology and Innovation for Aviation Safety. For this session, and this session will be moderated by Chief Wesley Carey of Remotely Piloted Aircraft System Section, Air Navigation Bureau of ACAO. So please.
Well, good afternoon, everyone. I hope you all had a good lunch, and I'd like to really thank the organizers for putting on a very nice lunch. Thank you. Just make sure I understand how this works. Okay. So this afternoon session, we're going to be talking about new technology and innovation for aviation safety. Well, one of the things that is clear is that the aviation system is constantly evolving. We have new changes coming to us all the time. So looking at technology, innovations, they're coming at us from every direction. And both of these present new risks to aviation safety, while also, with proper planning and understanding, they enhance safety. So they may have new aspects that they're bringing in, which is always a little threatening, it's always a little risky, but at the same time, more often than not, they're there to try and improve safety. So that's what we're going to be looking at. We have new types of aircraft conducting new types of operations. We also have new types of solutions for existing requirements and new data from both conventional and novel sources and ways of exchanging that data and information. We'll be hearing about several of those. So again, all of these present threats to civil aviation safety, but at the same time, they bring all sorts of improvements, from efficiency to access, security, and most importantly, to an even safer aviation system. The industry, the providers, and the regulators are all looking at how to maintain, if not improve, the aviation system, even as the system is expanding into new locations with new types of businesses. So for myself, we'll get into the introductions. For the last 16 years, I've served as the lead of the UAS and RPAS activity at ICAO. This has given me a front row seat at how we address aviation safety while facing a vast number of new technologies and innovations. And as the moderator of this session, it's my role to assist in increasing everyone's understanding of some of the new technologies and innovations happening across civil aviation and how safety is ensured or enhanced with their introductions. So I hope you'll all listen intently to the speakers and bring your questions to us at the end. So let me introduce the panelists. Now, we've already heard from Robert Reckert in the last session, but he'll be briefing us on what the United States Federal Aviation Administration is doing regarding harmonized development of RPAS and AAM into controlled airspace. Then we'll hear from Mr. Jinyong Hong, who is Deputy General Manager of the UTM and UATM Department of the Korea Airport Corporation, with responsibility for conducting NAVAID inspections. He will tell us about the introduction of Drone ILS VOR Analyzer, which is a new way of inspecting NAVAIDs and collecting the data. He'll be followed by Mr. Dongmin John, manager of the apron control team at the Incheon International Airport Corporation, who will inform us about the application of digital tower technology for ATC safety. He has a background as an air traffic controller and specializes in the analysis of using fast time simulation and contributes to the Smart Integrated Control Platform at Incheon Airport. And next we will hear from Crystal Kim, Air Traffic Management Technical Officer in the ICAO Secretariat, who will brief us on some of the upcoming ATM-related programs that are expected to provide many safety enhancements. And as the Secretary of the ATM Performance and Requirement Panel, as well as the Operational and Data Link Working Group, she really is a foremost expert on these topics. And she'll be talking to us about trajectory-based operations, free flight, and system-wide information management. So let's get started. And I'll talk to you first about what we're doing about getting RPAS, remotely piloted aircraft systems, into the conventional air traffic management operations system. We'll look a little bit at terminology, the categorization of these new types of aircraft, regulatory frameworks, the training courses, and upcoming events. But most importantly, when we're looking at unmanned aircraft, understanding that any aircraft that is intended to be operated without a pilot on board is an unmanned aircraft. But it's still an aircraft. It's not a vehicle, it's not technically a drone, it's not all sorts of things. It is an aircraft, whatever else it might be referred to as. Kind of like a cargo aircraft, a passenger aircraft, a commercial aircraft. It can be all of those. Then we subdivide unmanned aircraft into those that are certified. We have categories for specific and open, and I'll talk a bit about each of these. What I won't talk about are unmanned balloons. These are still unmanned aircraft within the ICAO framework. Free balloons, managed balloons, such as what the Google Loon balloons that used to be flying around the world as managed balloons. So we'll look at all of these a bit. Now, there are three different categories that ICAO has been working with. These categories were developed by JARAS, the Joint Authorities or Joint Authorities. Now that I've totally forgotten what this acronym stands for unmanned systems. They have the three categories: open, which is very simple, recreational type drones. Small professional drones that are flown visual line of sight, but always with very low risk to third parties. So those are regulated, but the regulations can be very simple. Then we have a specific category where the operations or the aircraft are becoming more complicated. They may not be just operated within line of sight of the remote pilot. They might be much further away, hundreds of kilometers away. Then we have the certified category. The certified category is what we're used to in civil aviation. This is the very prescriptive approach to airworthiness and operations, licensing, air traffic management. What we're looking at here is how to get aircraft ready to be operated in the conventional international IFR type arena, conducting standard operations. So this is very similar to conventional aviation, has most of the same types of requirements to it. So three different categories. There are no clear distinctions between the categories. It's all kind of a gray area, but it's operations or aircraft become more complicated, they slide across this scale. And with the scope of ICAO's work, looking at the blue section at the bottom, the open category is very low risk. Very few people that would be affected if anything goes wrong with the operation. We have model regulations covering this called Part 101. Then the specific category there in the middle in the green, where there's a medium level of risk. The regulations become a little more complicated to match the risk to third parties. That's Part 102. And then the certified category, where we're talking about ICAO annexes, standards and recommended practices within the annexes. Well, first we'll go into the certified category. We've had an expert group at ICAO comprised of individuals from around the world, both from industry and regulators, that come together as the RPAS panel. And they've been developing SARPs ever since 2014. This is the primary focus of the work at ICAO on remotely piloted aircraft, or unmanned aircraft of all kinds. And looking at international operation, how to get these aircraft ready to be operated as part of that regular system in and out of airports, flying in and out of Incheon Airport, going to Narita. So these aircraft then have to be certificated in accordance with Annex 8. The airworthiness standards are already there in Annex 8 on how to certificate remotely piloted airplanes, remotely piloted helicopters, and remote pilot stations. So the approach on this remains consistent with conventional aviation, requires a traditional certification process, and it does not diverge unless there is really a need to do so. So a remote pilot station is not on the aircraft. It's not the flight deck, it's not the cockpit, it's a remote pilot station. It is separate, but it has the same functionalities. So there is divergence. And we're really looking at long-haul type operations with many of these. Think of it as an A320, except that there are no pilots on board the aircraft. And these aircraft that can be airborne for days or weeks or even months at a time. So they're not just taking off from one airport and going and landing. A few hours later, they may be airborne for days on end. Oh, we've already completed the remote pilot license. After all, piloting these aircraft remotely is not the same as being a pilot on board an aircraft. So, what are the new kinds of requirements for that remote pilot? A competency-based license that contained in Annex 1. These were applicable November of last year. So these standards are all there ready for use, along with the competencies that are identified in the PANS training. We have a type certificate process and the certificate of airworthiness. These are contained in Annex 8, just as for other airplanes and helicopters. These are effective now and applicable in 2026. So applicable meaning that they are, at that point, mandatory for use. Right now, they can be used on a voluntary basis. And just like for air operators that have an air operator certificate, commercial operators, we have developed an RPAS operator certificate. This is not just for commercial operations, however, it's for any and all international operations. We do not distinguish between commercial air transport and general aviation or business aviation. We've done away with those distinctions and just said, if you're going to operate a remotely piloted aircraft internationally, you have to have an RPAS operator certificate from the state of the operator. So this is contained in Annex 6, Part 4, which is not yet in place. It's undergoing the approval process at ICAO currently. It's already been out for state comment. All of those comments are being assessed and responded to, and that information will all then be taken and presented to the Air Navigation Commission later this year. But we anticipate that those standards will be adopted in March of next year. Safety Management System, Annex 19. Likewise, that is in the review process now as part of the approval process. All with the same deadline, November 2026 for applicability. And ATM and various contingency procedures. So contingencies, things like the C2 link that connects the remote pilot station to the aircraft. If that fails, what is the aircraft expected to do? What is the remote pilot expected to do? What does air traffic control do in response? So these procedures are all there, going into the approval process as we speak. So that's the certified category, the very high end of these aircraft. But that's actually not where most of the aircraft reside. So what about the other categories? We've got the open category, where we have the UAS model regulations. This is guidance material for civil aviation authorities to make use of. They can take these regulations, put them in place for their own state, make the adjustments as necessary, but it has a comprehensive, albeit very baseline set of regulations. And these are based on existing regulations, particularly from New Zealand, but with additions from other countries. The regulations do cover remote pilot licensing. If you're not doing international IFR type operations, your requirements are not going to be nearly as stringent. So the licensing requirements within these model regulations are appropriate for these smaller domestic type operations. But they still include things like safety management, because we really never get away from the need to assess the risks, hazards, and build our safety management around that. The guidance material really provides best practices that has been learned from multiple states, and it's a living document. We keep it online, available for everybody to download as they need and make use of. The types of requirements for this open category. We're looking at aircraft 25 kilos or less, so not particularly large. Types of use cases, real estate, photography, most significantly recreational users, but there are a lot of businesses that make use of these aircraft. Conducting operations visual line of sight, where the remote pilot can always see the aircraft and the sky around the aircraft to ensure that there are no other aircraft or other hazards that might be encountered. Now, we have the specific category, which is the big gray area between the very simple open category and the very complicated certified category. At this point, we don't have certification standards for these aircraft, but a lot of them will be used for conducting international operations. So we need to be aware that how we are going to move forward with this specific category is likely going to be rather complicated. We have in the requirements here in Part 102, there's a means to issue various certificates for the operator as well as the remote pilot. It takes an operation-centric, risk-based approach. So what the operator is going to do with a particular aircraft in a particular location might be approved, but change the location or change the aircraft, and the operation might not be approved. It depends on how the combination of location and aircraft and what the operation exactly will be. All of that is taken into consideration. It also includes requirements for manufacturers. So a means of compliance, declaration, requirements for documentation and records, but all of these are scaled down dramatically from what we're used to across civil aviation. Now, all of the regulations, these model regulations, advisory circulars, are available on the ICAO public website. We include with it as well information on the carriage of dangerous goods on these small aircraft. It is amazing, especially during COVID, but for other humanitarian purposes as well. Vaccines, syringes, and needles were often being delivered by drones. So we needed to develop guidance material, and the Dangerous Goods panel at ICAO worked on this with us to try and make it as appropriate as possible for these types of aircraft and operations. We've been working to develop various training courses. We have 4 different courses online at this point. One on an overview of unmanned aviation fundamentals. We also have a course on operations, one on regulations, and another on safety management. So these are all courses that you can register for them through the ICAO Global Aviation Training Group. And we have a 5-day in-person course, Unmanned Aviation Fundamentals. This is really aimed for Civil Aviation Authority personnel that will be working to develop policies or regulations and how to implement those within the CAA. We're really trying to target middle management level for this course. It covers policy development, regulations, safety and operations. It also gets into some aspects like how to put together a communications package to tell stakeholders, the public, operators, conventional aviation in the state, what the CAA is doing with these regulations. And finally, we have an ICAO IPAC, an implementation package for states. We've been getting some really good feedback on this. We have a dedicated subject matter expert who works with the individual CAA and provides a great deal of training. We have the tools available and documents that the SME works with the CAA to help implement based on what their current level of implementation already is. And then we have 2 upcoming events. Drone Enable, which many have probably heard about. We've been conducting these for several years. Drone Enable is our way of trying to get information directly from innovators on what are the solutions that should be put forward into guidance material. We started out with things like how should we accomplish remote identification of the aircraft? We've talked about how to integrate air traffic management and UAS traffic management ATM and UTM, what are the boundaries between those? What information needs to be exchanged? Communications, what are the types of, or what kind of communication systems can be used for UAS traffic management? So we hold one of these each year, putting out a problem statement, asking for people to come tell us the best way to solve the problems. And then next year, in September, we will have the first Advanced Air Mobility Symposium, looking at all sorts of things that are coming, the electric, vertical takeoff and landing, aircraft, passenger carrying in particular. But AAM is much more than just those. It's also UAS. It's also UTM. So looking at that entire environment, we hope to see you there. And with that, I'll say thank you and invite Robert to come take over and present on what the FAA is doing. Thank you.
Good afternoon, everybody. Thanks again for having me, and my apologies for having to listen to me twice in one day, especially after lunch. Hopefully I can maybe get a couple smiles or something, keep everybody awake. But here to talk about the agency's efforts around advanced air mobility and update around what we're doing with advanced air mobility and unmanned aircraft systems, or UAS. Please bear with me as this presentation went through a lot of levels in our organization, and I recognize some of the time challenges we have. So some of the slides I'm going to move a little quicker on and then pause on some other slides, if you will. So the first few slides really just talk about, green button's supposed to work. There we go. Really just talks about our organizational structure, right? So here's what the flight standards service looks like within the FAA. And you can see the 4 white boxes below the blue boxes really just highlight the 4 functional areas that we've organized into. The Office of Safety Standards, where I work, we have a multitude of staff with different responsibilities, and just wanted to highlight the complexity of the challenges with an organization as large as the FAA. And then finally, our FAA UAS integration, or excuse me, AUS UAS integration office, which sometimes, quite honestly, due to the size of the organization, that we struggle honestly internally about what and how we work together, and which is what makes collaboration so important between the different organizations, as we do have different responsibilities, but we have the same goals moving forward. First slide that I'd really like to maybe take a minute and really talk through is very similar to what the material previously presented was. What's our emerging entrant integration strategy? Similar to how ICAO is looking at things, we're looking at it the same way we're looking at things on the risk continuum or the safety continuum, where we're willing to accept more risk, less regulatory structure when we have low complexity, low risk operations. And obviously, as we move up the safety continuum, whether that's the societal risk or the society's perception of the risk, safety, regulatory structure needs to be strengthened. Obviously, recreational visual line of sight operations have obviously a lower risk and a higher risk tolerance than passenger carrying operations under concepts such as advanced air mobility, et cetera. Apologize for the small type on this one. I'm even having trouble reading it from up here a little bit. But our drone integration strategy really focuses on our implementation and our priorities and activities. What is the strategy? It's mapping out all the tasks that have to happen to bring those new technologies and new aircraft into the system. For a long time, we used the term normalize. If you've heard that from the FAA before, really just represents how do you take a new technology, a new way of doing things, bringing it into your system and integrating it with all of the components, whether that's licensing, certification of the aircraft, operation in the environment, et cetera. From a strategic perspective, that we wanted to kind of in that same philosophy of crawl, walk, run. That's the idea of having incremental steps, being collaborative with our stakeholders, whether that's industry or our internal partners within the agency, and that the strategy was holistic and encompassed, all of the different parts of the system, right? The aircraft, the airmen, air traffic, operations, ground infrastructure, et cetera. This is one of those slides that I think everybody calls the wow slide, right? We think we've got 2 of them here, but it's big numbers that we're dealing with. I'm not sure, and I'm happy to talk through after with anybody. 878,000 registered drones in the United States. That's a lot of drones. 320,000 remote pilots. But I think what some of the positive sides of all of this show that the societal acceptance of these types of operations is growing, whether it's industry, academia, collegiate schools, training, et cetera. Folks are embracing the technology and moving forward together. Industry trends. Lots of airspace authorizations that we spend a lot of time on. That's almost 1.5 million or 1.4 plus airspace authorizations and 345,000 commercial drone registrations. You can take a look on the right-hand side, delivery flights. We have a number of certificated air carriers right now in the United States that had participated in some of our pilot programs, and I don't mean like pilots as in something new, but our pilot programs with 6 different air carriers, and you can see the number of delivery flights. Very vastly different business models, from delivering packages to moving medical test samples, from hovering UAS with lower packages on winches to optical scanning systems to detect obstacles on the ground, to flybys with parachutes. All very interesting technology and all very different ways of looking at similar operations. Getting into some of the meat and potatoes about how, about how our system works in the United States. What we will do a lot of times to propagate a rulemaking is form an aviation rulemaking committee. And what an aviation rulemaking committee is a sanctioned body by the FAA that consists of subject matter experts and industry representatives. And we do this in a lot of different areas, from air carrier training through UAS. One of the most recent ones that was completed was our Beyond Visual Line of Sight, or our BVLOS ARC. That ARC had come up with 5 sets of recommendations that they had put into 5 buckets, if you will, around risk tolerance, operations, the operator, the aircraft, and how third-party services can be involved. The ARC has completed its work and provided its recommendations to us as an agency, and we're working through those recommendations together. Next slide's really more about timelines. And again, I think the lady that was facilitating at the beginning had said these presentations will be available via PDF or electronically, so I don't want to spend too much time on the timeline. But as you can see, this is our timeline around remote identification and our implementation timeline update. How we got here, in October of 2022, we had started accepting applications for organizations to be represented as CBOs, or community-based organizations, that could then build and identify an area where the aircraft could operate, recognized identification areas. We've not actually had anybody actually apply for that at this point, but you can take and click on and follow the link to that process and get more information around how that process works. Safety risk management, this is aviation, right? We need to learn, we need to be proactive. We need to incorporate the pillars of a safety management system. SRM is very important to us also internally within the FAA. I'm not sure about other CAAs, but as a regulator, we have implemented a safety management system within our organization as well. And we've identified some priorities for the organization. Our order 8040.6, which is available online, probably can find it via Google or any other search engine, is our internal safety risk management policy. We're currently updating that to include some unmanned aircraft system safety risk management policy and to include a new updated safety risk assessment process for how we conduct risk assessments, make policy decisions, and then collect that data and analyze the safety risk for the operations. All righty. Another ARC that we have moving along is our UAS Detection, Mitigation, Aviation Rulemaking Committee. So this is another ARC, again, Aviation Rulemaking Committee, which is a group of industry recognized experts that are accepted into this team to develop recommendations for the expanded detection and mitigation of unmanned aircraft systems. That's with manned aircraft, infrastructure, ground, et cetera. How do we incorporate UAS and those type pieces? 58 members working to provide recommendations that are supposed to be due in early 2024. On a side note, every time we form an ARC, there's a charter that goes with it, describes interests and deliverables and a timeline for the membership. The ICAO Remotely Piloted Aircraft Systems Panel Outbrief. I am not going to, I don't know enough on this subject to really dive into that, so I really wanted to be pretty honest about this one. My understanding is that we've submitted 8 working papers to ICAO and to include initial concepts for an infocentric or for infocentric NAS, and we've, let's see, and have incorporated feedback and practical lessons learned from some different European studies and standardized scenarios for developing SARPs and other testing models for UAS within the United States. So, getting into where, that's a bit of the background, getting into where are we going. What's the pathway forward for UAS and AAM integration? Every country is a little bit different, right? In the United States, we have federal regulations, we have state regulations, we have local regulations, and in some areas, we even have tribal regulations. Coordination amongst all the regulated entities or the various levels of government is really important. We've seen a lot of local state municipalities lean pretty far forward in the UAS AAM space to incorporate this technology, whether that's police departments, infrastructure inspections, et cetera. And one of the key components for us as the regulatory agency is that cooperation with our state and local governments. We're hosting, let's see, the 8th annual FAA Drones Symposium and the first ever Advanced Air Mobility Summit this summer. Our AUS organization will be sponsoring that. These 2 events in August, located in Baltimore, Maryland, will bring representatives from the FAA, other government agencies, international experts, and industry leaders in academia together. If you want to register or would like to learn more information about the symposium and summit, the links are on the slide and will be available as part of the presentation. I think as an agency, we've been pretty successful in incorporating new technologies. I think what's challenging about UAS and AAM is they challenge us in how we look at safety, how we look at our regulatory structure, and how we incorporate operations. Technology has constantly been changing as an organization and as an industry. It's about how we structure ourselves in our regulatory system to be able to embrace innovation without changing that safety bar for the different entrants into the system. AAM, I was talking to some of the folks at lunch. For a long time within the United States, the term AAM was a pretty nebulous term. It represented a lot of different things to the point where, quite honestly, when we look at some of the proposed operations with AAM aircraft, let's call it piloted eVTOL type aircraft, from one perspective, our regulations already support those types of operations. The power source is different. The mode of flight's a little different, but it's an aircraft, right? It's piloted. But once we got, and there was a lot of conversation back and forth internally, the Advanced Air Mobility Coordination and Leadership Act that came out of Congress, our United States Congress in October of last year, put into legislation how we define AAM. And AAM is defined within our legislation as a transportation system that transports people and property by air between 2 points in the United States using aircraft, including electric aircraft or electric vertical takeoff and landing aircraft in both controlled and uncontrolled airspace. The Department of Transportation, which is the larger agency that the FAA falls under, expects our discussions and our focus to include how we integrate AAM into our existing integrated transportation structure. So how do we incorporate AAM into rail? How does it incorporate it into other bus and passenger traffic and that type of business so that it creates a more integrated and seamless transportation structure within the United States? Pretty neat stuff on the drawing board. I think a little more than even on the drawing board, right? Most of these aircraft are flying within in a space of research and development, but really represent different philosophies, different designs, and different ways of looking at the challenges that are in front of industry. But it's just a sample. The slides just highlighting a sample of the different electric vertical and takeoff aircraft that we're involved with here with the FAA. If you look in the bottom row, let's call it third from the left, that's a Cessna Caravan, right? So that's not a electric VTOL aircraft, but that is an aircraft that we are involved with a number of different projects where that aircraft is being modified through a supplemental type certificate to be able to be operated unmanned, to be able to move packages within the United States. So what makes that interesting is you have a type certificated standard category aircraft that's being modified through a supplemental type certificate process to be able to be flown remotely in a cargo configuration. Within flight standards, within the United States and within our flight standards organization and our functional organization, our responsibilities are pretty broad in how they go across the organization. On the left of the slide, you can see our Office of General Aviation Safety Assurance, or our one of our two safety assurance organizations, and how they fit into the AAM model, right? Issuance of air carrier certificates, approval of training, pilot training and maintenance programs, issuance of operations specifications, et cetera. On the right, highlights the responsibilities of the Office of Safety Standards, where I work to develop policy, training requirements, et cetera, regulations for the folks on the left to actually be able to implement. And really is just trying to highlight the need for cross-organizational collaboration to be able to make sure UAS, further integration of UAS and AAM is successful. Within one of our safety standards organizations is our Aircraft Evaluation Division, and they are they are developing flight standardization board and maintenance review board policy to be able to support, and they were developing that policy now to be able to support the certification of these aircraft. I think we had talked a little earlier about it's okay not to have all the answers up front. And I think that's something that we definitely recognize organizationally is we don't have all the answers up front, but what we can do is we can develop processes to be able to address the questions when they come up. And this is just highlighting two very important pieces of our system around how we maintain aircraft and how we qualify our pilots. Recognizing the time, I'm going to speed up a little bit, so my apologies. A couple things that are a couple of the next items I really like folks to pay attention to. First is the integration of powered lift pilot certification and operations. This is a rulemaking that we've conducted within the FAA about how we are going to certificate our pilots for eVTOL and AAM aircraft. That rule should be out later this month. So based on the way our structure works, I can't talk to you about what's in the context of that rule, but what I can share is the rule is around how we are going to certificate these pilots, and that rule will be available to the public this month. Another rule that we just recently completed, which was to facilitate powered lift aircraft, was the recognition of military piloting command experience, and that rule published in September of last year, and that is available on the U.S. government's Federal Register website. The next two items also are regulatory updates to incorporate powered lift and eVTOL aircraft. The first is the update to air carrier definitions. That was published in December of last year. What does that do? Quite simply is it takes a lot of our regulations where it says airplane and changes it to aircraft, right? It's structured to be inclusive of the new entrants. And then finally, airman certification standards and practical test standards for airmen, incorporation by reference. Obviously, if we're going to certificate pilots for new categories and classes of aircraft, we need to have airman certification standards and or practical test standards. If you want to know the difference, please see me on the side. I'm happy to explain. But we published that. Those comments were due back on the Federal Register by February, and I believe later this summer that that rule will be published, which will provide the certification basis for a pilot applicant for those ratings. Urban air mobility. UAM, so I know there's a lot of acronyms floating around, AAM, UTM. UAM is one that we're using, urban air mobility, which highlights the use of AAM aircraft in the urban environment. At the bottom of the slide, there's a click, you can click on the link, and that'll take you to the FAA's concept of operations for UAM. You can take a look at the bottom right corner of the slide and really just very simply highlights a delineation between uncontrolled airspace, controlled airspace, and the establishment of a UAM corridor, and that the concept of operations goes into much more detail about how aircraft will be able to enter and exit the UAM corridor, how they would do that under visual instrument flight rules, et cetera. Especially for this seminar and meeting today, I think this is great to highlight the U.S. government and Republic of Korea collaboration. And just wanted to highlight that back in January of this year, the FAA and KOCA, the Korean Office of Civil Aviation, agreed and signed an agreement to partner on future AAM aircraft development and operations. The two organizations work together to promote safety oversight, including airworthiness, licensing, and operations, and it highlights similar agreements that we have not only with South Korea, but also with Japan, the United Kingdom, Canada, Australia, and New Zealand to develop and harmonize our certification, operations, and integration plans. Based on the time, I'm going to move on. And move to our last slide here. Innovate 28 is the last item I'd like to to highlight. Innovate 28 is the administrator's initiative to integrate AAM into the NAS. We're working to finalize our Innovate 28 implementation plan, hopefully this month within the FAA. We're increasingly working together for the safe integration of drones and AAM into the national airspace, and we're moving quickly to keep up with the fast-changing environment we face. We issued a Federal Register notice on November 8th, which proposed the first airworthiness criteria for an AAM vehicle. AAM operators are sharing their plans that they would like to begin commercial operations as soon as 2025. We expect the first AAM aircraft to begin commercial operations in 2025 or just thereafter. It's our position that the FAA's current regulatory framework, with some updates, some new rules, and some flexibility, will be able to support industry's efforts to achieve their near-term AAM goals. The FAA has already proposed several of those rulemaking efforts. Near-term operations will be piloted, type-certificated VTOL aircraft operating in currently defined routes and procedures. The FAA may utilize waivers and exemptions when required, and to enable initial AAM operations, the FAA is developing a special federal aviation regulation, notice of proposed rulemaking to create a regulatory framework to permit operation of powered lift aircraft. That is the rule that I just referred to that will be out later this month on the Federal Register. It will propose and define the final rule will be out. It will define alternate eligibility requirements to safely certificate initial groups of powered lift pilots, as well as to determine which operating rules to apply to powered lift aircraft. Powered lift will be type certificated as a special class under our existing regulations, and the public will have an opportunity to comment when the NPRM is published. And with that, I know I'm over, and my apologies.
Good afternoon. My name is Junseop, KAC Air Navigation Facility Office. Today, I will present how KAC utilizes DIVA to inspect air navigation facilities. The name of DIVA stands for Drone ILS VOR DME TechN Analyzer. The contents as follows. Overview. Performing ground check to measure navigational signals is an important step in verifying the performance of NAVAD at airports. To ensure the performance of air navigation facilities for safe aircraft operations, maintenance operators need to directly measure the signal quality from locations such as airport runway or rooftop or airport buildings. The photo on the right shows the inspection being conducted by ascending another near mountain to measure the signals of VOR or TechN installed at the mountaintop. It is important to keep in mind that ground measurements may not always reflect the radio performance that actual aircraft experience in flight. This is because factors such as surrounding man-made obstructions, radio frequency interference, can affect the radio performance measurement on the ground. In accordance with international standard and aviation safety laws, we regularly undergo inspections using actual aircraft for flight checks. If we receive an unsatisfactory rating during the flight check, we are unable to use the facility until we pass a re-inspection and receive a satisfactory rating. In some cases, this may lead to unable to operate the airports. Therefore, the Korea Airports Corporation conducts precise inspection on a 24/7 basis, 365 days a year, using a shift-work system at over 80 locations to ensure uninterrupted operation of the air navigation facilities. To overcome the limitations of conventional ground inspections, Korea Airports Corporation has successfully reduced the weight and size of the 30 kilograms radio measurement devices typically used for ground checks. These compact and lightweight devices have been effectively incorporated into drones, enabling their deployment and utilization in the field. For example, using a drone to inspect the VOR taken installed on the top of the mountain can significantly reduce the time reduced for inspection, from approximately 5 hours for ground inspection to just about 30 minutes with a drone. This not only saves time, but also reduces the risk associated with climbing mountain for ground inspections. In addition to being more efficient, using drones for inspection also allows for more frequent inspection to be carried out. This can help to identify any issues or maintenance needs more quickly, leading to improved safety and reliability of NAVAID. In addition, using drones for inspection can provide smaller benefits to flight inspections without the need for additional cost. DIVA development and utilizations. Korea Airport Corporation's DIVA system is an advanced technology system designed to check the performance of navigational facility, including ILS, VOR, DME, and TechHand. The system has been developed with user-oriented GUI to make it easy to use and understand. The development goal of DIVA is to create a lightweight and compact device with user-friendly performance, reducing the burden to drone operator during flight. Additionally, it aims to minimize the risk associated with drone weight that can lead to accident in the event of a crash. DIVA system consists of a drone, a controller, RTK, and ground station. RTK is used to ensure the precision of drone flight, while the ground station is utilized for real-time analysis of the major NAVAID information. The key features of DIVA, as shown on right, include capability of simultaneous inspect, localizer, and glide slope, VOR and DME, as well as VOR and TechHand. Another important feature is ability to generate inspection results in a format similar to the flight check report. We have developed a dedicated antenna that can be mounted on drones for navigate the signals. Through three-dimensional RF simulations, we have developed an antenna optimized for signal measurement and compatible with drone installations. KAC not only measures the radio signals, but also applies a flight inspection path to design the drone's flight inspection route. The diagram on the left shows the flight inspection route. Typically, starting from the point 10 nautical miles away from the end of the runway, multiple flights are conducted along complex routes to measure the radio signal quality. The motion pictures on the right shows the flight path of drone. In a shorter flight range, we can obtain the information that would typically require a wider flight range. This allows us to assess and gather valuable data within a limited flight range, which would otherwise require a much larger area to cover. The video you are currently watching shows Sierra Echo Lima VOR Tech. By utilizing drones, it has become easier to conduct comprehensive checks on the entire range of signal quality, whereas previously, only limited inspections were possible from the mountain peak. By applying a DIVA system, it is possible to track the position of man-made obstruction causing radio interference when navigation signals are distorted. As seen in the picture below, the signal impact of glide slope due to obstacle located at end of the runway can be determined by conduct DIVA flight. This enables the combination of obstacle position and their influence caused by radio interference. DIVA is deployed in 6 airports nationwide under the management of KAC, and it is utilized to maintain the performance of air navigational facility in civil military airports and navigational stations. Through drone inspection aligned with the flight check schedule for each facility, the performance of air navigational facility is verified. DIVA is also used for analyzing the cause of abnormal conditions when they occur. The DIVA has been exported to other groups. As an example of export, in 2019, we delivered 5 DIVA to Republic of Korea Air Force and provide technical support. And this year, we are participating in project of MOLIT navigational facility management system, supplying DIVA and provide technical support. Our DIVA system has also been introduced internationally. From 2019 to 2022, we collaborate with the Inter-American Development Bank to conduct drone inspection demonstration and provide technical consulting for navigational facility at Pereira International Airport in Colombia. We inspected and confirmed the satisfactory condition of localizer, glide slope, VOR, and DME at Pereira airports. Procedures. Now briefly explain the procedures for operating DIVA. The first step is automatic flight path generation. As shown in the previous video, the drone flight path for performance verification of each facility can be generated using the automatic flight path generation software. By inserting information such as the GPS coordinate and magnetic bearing of the facilities, drone flight paths for inspecting the facility can be generated. This slide presents images visualizing the flight paths of our drone created using Google Earth. These images were generated by our software. Operator's GUI screen is showing measuring both localizer and glide slope signals at Gimpo airports. The performance verification items for each facilities are displayed in a user-friendly format. Real-time graphs are available for key parameters, and drone speed, altitude, distance, and direction can also be monitored during the flight. The drone's flight path is also displayed on real-time screen. Satellite metadata can be viewed on the operator's screen when there is an internet connection at the site. Once the drone flight is completed, the result graph is automatically generated as this. It is provided in PDF and is essentially the same as the result graph of the flight inspection. Although the drone flight path is limited compared to the aircraft flight inspection, the results are very similar. This drone inspection result represents the approach flight result of localizer, and it allows for checking modulations, width, symmetry, alignment, etc. This screen displays the drone inspection result for localizer with a clearance of 35 degrees. It allows for checking modulation, DDM, and power for each 5-degree angles. The graph provides a visual representation of key parameters. On the following pages, we have also included inspection results for VOR, DME, and TACAN. So you can check later if you're interested. The final step of drone inspection is compare analysis. Multiple inspection data can be simultaneously displayed and compared. The current screen shows the comparison of 4 inspections conducted on Anyang BOR. It confirms that facility is operating within the normal range. Case study. Other countries are also conducting research on using drones for inspection of navigation facilities. Germany, Switzerland, Spain, and more. And some companies have reached the commercialization stage, and they are exporting their drone systems automatically. Some countries have adjusted their flight inspection periodicity. According to ICAO document 8071, if the interrelation between flight inspections and drone inspections is demonstrated, it is possible to adjust the flight inspection periodicity. This is the result of the Yeosu Airport runway 17 ILS drone inspection. On the left side, you can see the flight inspection result conducted on May 16th. On the right, you can see the drone inspection conducted on the following day, May 17th. When compared the inspection result, it can be observed that the key parameters of localizer, such as modulation and width, are almost identical. This page provides our main parameters of glide slope. Similar to localizer, the results of each items are similar to the results of the flight inspection. I believe we are at the beginning stage of utilizing drones for air navigation and facility inspections. We are conducting regular drone inspection and hoping to support safe aviation operation with new technology. Thank you for listening.
Good afternoon. It's an honor to be here today to present about Smart Integrated Control Platform of Incheon Airport. A Smart Integrated Control Platform is a project name that applying digital tower technology to Incheon Airport air traffic control towers. Even though digital tower is the ATC system, ATC field is closely related to flight safety. So I had chosen this topic for my presentation. Today, I will present about the functionalities of a Smart Integrated Control Platform and how digital tower technology is being applied to Incheon Airport, as well as how contribute to aviation safety. In this room, some of you may already be familiar with the concept of a digital tower, while others be hearing about it for the first time. A digital tower is an advanced system to provide controllers with a view of the aerodrome and its vicinity. The video is from cameras installed on top of the air traffic control tower or other elevated structures. Then controllers, instead of referring to out-of-window view on the physical tower, can monitor transmitted video on the digital tower display. This means digital tower can replace the physical tower. Then there is no longer necessity to construct high tall physical tower. Then we can reduce the construction cost for building air traffic control tower. And also, digital tower can be located anywhere. Air traffic control can be conducted from office space on a first or second floor, not high floors like air traffic control tower, and also from a location a few kilometers away from the airport. In fact, it's also possible that controlling the aircraft in your home. Certainly, it requires the security personnel in your home as well. So then, do you know how many air traffic control towers at Incheon Airport? That's correct. There are a total of 3 control towers at Incheon Airport. One is main control tower, and other 2 is apron control towers. Main control tower is in charge of maneuvering area, including 4 runways and parallel taxiways. And apron control tower 1 is in charge of Terminal 1 and concourse and cargo terminal 1 and 2. And apron cargo 2 is in charge of Terminal 2 and maintenance area. Then one might question, why Incheon Airport discuss digital tower? There are already 3 control towers in place. That's correct. We have established already 3 control towers and covering all control areas effectively. And one might also consider if there's a system error with a digital tower system in a large airport like Incheon, wouldn't it potentially cause a significant confusion at the airport? That's also correct. There's no airport having digital tower in Korea yet, so we don't have any experience of operating the digital tower. In particularly, in large airport like Incheon, the thorough validation is necessary. Despite these concerns, we are applying digital tower technology to the Incheon Airport. I will explain why. These factors are reason why we consider digital tower. Incheon Airport had faced a significant decrease in traffic volume due to pandemic. However, we anticipate a recovery and continuous growing in the future. As a result, the airport is expanding continuously to accommodate this growing. So control areas of Incheon Airport and workload for controllers will be increased in the future. Another factor is about aircraft surveillance. The air traffic control tower is strategically positioned the best location to oversee all area. However, there are blind spots as shown in the picture. Aircraft are obstructed by terminal buildings, so controllers cannot see aircraft. Especially in adverse weather conditions like low visibility, it makes visual observation impossible. So controllers heavily rely on the radar system. So these factors can be potential risk in ATC field of Incheon Airport. Except for these factors, additionally, unexpected event or human factor of pilots or controllers could be potential risk in ATC field. To address these challenges, we considered digital tower technology. Digital tower technology not only replaces a conventional physical tower for cost savings, but also provide additional functionalities not present in physical towers. However, as I mentioned earlier, we don't have any experience of operating digital tower, and complete transition to digital tower comes with risk in large airport. So our approach is applying digital tower technology to Incheon Airport current physical tower, like this video. The video is not played, so yeah, this is a smart integrated control platform's configuration. The The digital tower display will be installed above ATC console in current Aviation control tower. Aviation control tower is in charge of ground control only, so this installation doesn't interfere the controller's duties. So controllers can look out of a window for visual observation as usual, and also can the digital tower display when necessary. We can get both benefits of digital tower and physical tower. This is a smart integrated control platform's display. Among whole display, the central large display is called panorama view. It displays whole control area. For this view, the cameras are installed on top of air traffic control towers. Stitching technology creates panorama view of whole control area. This is gate view. Typical digital tower provide only panorama view of whole control area, but in case of smart integrated control platform, around the panorama view, there are gate view displaying the status of gate. These are functionalities of smart integrated control platform. First, these features within panorama view. First, integration of various information. Normally, air traffic controllers monitor multiple screens such as ASDE, SMGCS, strip, weather. However, by displaying of various information, including aircraft symbol, flight information, NOTAM, ACDM on panorama view, the controllers can obtain all necessary information from one screen. So before smart integrated control platform, the controllers look out for visual observation of aircraft and head down again and monitor multiple screens to check the aircraft information. But in smart integrated control platform environment, the controllers obtain all information with a view from one screen. Second is enhancement of aircraft surveillance. Utilizing AR technology, the system provides virtual outlines of aircraft, terminal, and taxiways. So it allows for controllers visualize the aircraft position exactly, even in low visibility conditions. A third is improvement of controllers interface. For example, the installation of pan tilt zoom camera, it allows for efficient and automated tracking of the aircraft. It eliminates needs for control of CCTV or reliance on binoculars. So these features can improve the controller's aircraft surveillance capabilities and decrease the workload for controllers. There are features within gate view. Individual cameras are installed at each gate and display departing and arriving gate automatically. The cameras utilize video recognition to identify the gate conditions. The cameras identify all features on gate, such as boarding bridge or towing car and marshallers, and provide the visual confirmation to controllers. For example, it provides message that boarding bridge disconnected or towing car connected, or all marshallers are ready for arriving aircraft. So controllers can know about the status of gate directly. The camera also identifies the ground handling equipment and provide the status of ground handling operations. This data could be used to predict the aircraft departure time or link with ACDM or total airport management. These features are ATC assistance tool. The system monitors all control area for 24 hours. And if it predicts the collision between aircraft and vehicle or detect abnormal situations such as FOD on taxiway or fire or smoke, then it notifies to controllers to respond quickly. The system also monitors the aircraft movement. If the aircraft is about to enter wrong taxiway, not instructed, then it provides alerts to controllers. Then controllers can give the revised instructions to pilots and to prevent a potential event. Last is utilizing voice recognition. If miscommunication or incorrect readback between pilots and controllers, then it provides warnings to controllers to prevent miscommunication. So these features can prevent the abnormal event in the airside and mitigate potential risk, thereby contributing to safer and more efficient aircraft operations. So far, I have talked about the concept and functionalities of Smart Integrated Control Platform. A Smart Integrated Control Platform project is divided into 2 stages. In the first phase, we deploy in Terminal 2 area initially until next year. And in second phase, we will expand to entire airside. We believe this system can enhance the operational safety and improve overall efficiency in Incheon Airport. And based on this experience of applying digital tower technology, we are considering building a remote tower. The master plan about Terminal 3 and 5th runway in progress in Incheon Airport. And for this area, we are considering building a new remote tower instead of building a physical apron control tower. Thank you, and I hope the content that I present are informative of you. Thank you.
I think I'm too short, so I need to readjust the mic before I start. Good afternoon, everyone. I'm Crystal Kim, Technical Officer of an International Civil Aviation, and also known as Kim Gu-sil in Korean. I'm really happy to be here today with you, with my old friends from Aviation University and my colleagues from the Ministry of Transport, and it's a special opportunity. So once again, my sincere and special thanks goes to the Ministry of Land and Transport, Ministry of Land, Infrastructure and Transport for giving me this opportunity to speak at this event, the very event that I used to organize back in the days when I was working for the ministry. I'm here today to share with you the ongoing developments of global air traffic management concepts, which you will see the aggregation of the innovations and the technological advancements that we've been witnessing today, and also heard a lot in the other event, GISS 2023. When it comes to the ATM concepts, there must be different terms that may come across to you. Someone will think of TBO, someone will think of AAM, or SWIM, FFIs, STM, and UTM, you name it. Today, I would like to talk to you about some of those concepts, and also will conclude with information on upcoming global events that ICAO is organizing, where you can learn more about these concepts, and also upcoming actual application of those concepts in practice. How many of you know about this document? Has anyone ever heard about this document? Yes. I'm very happy to hear. Thank you very much from my ICAO colleagues. Let me start with this very important document. It's called Global ATM Operational Concept, commonly known as GETMOG. The operational concept was intended to guide the implementation of CNS ATM technologies. Nowadays, satellite-based technologies are not considered innovation. It's a norm, right? But back in the days, when I was in the university, that was something new, something very cool. So in those days, the global aviation community called for a need to develop a global ATM operational concept to describe what is envisaged in the future ATM system. It included a vision statement, guiding principles to transform the ATM system towards this envisioned end state, and also description of 7 concept components in the area of airspace management and optimization, airspace users operation, traffic synchronization, conflict management, demand and capacity balancing, all these familiar words that you're using, but all those are coming from this document. It also laid out the ATM system requirements and performance. As a guiding principles for safety, this document also outlined a total system performance framework, including a system safety approach that will support both end state of concept and the various evolutions from concept through design, development, operation, and maintenance. However, it was not meant to be a technical manual, nor does it detail how things will be enabled. Subsequently, ICAO was called upon to develop more detailed concept of operation or concept of use, and more guidance on the performance-based approach in planning and implementation of this operational concept. All these documents have been as a foundation for today's famous Global Air Navigation Plan, which details the path and steps to realize the vision and concept outlined in this original operational document. So any of you who wish to study GETMOG, the GAMP, GETMOG is a very introductory document that you can study before you jump into the GAMP. The GETMOG has been serving as a very stable reference for the evolution of an ATM since its publication in 2005. Almost 20 years ago, with the vision statement which reads, to achieve an interoperable global air traffic management system for all users during all phases of flight that meets the agreed levels of safety, provides optimum economic operations, is environmentally sustainable, and meets national security requirements. All these important keywords that we're striving for today were all carved into those vision statements, which is still valid today. However, GETMO was developed based on the limitations on the provision of air traffic services in 2000, with a clear focus look ahead on 2025, which is around the corner, and did not encompass emerging issues and innovations affecting the evolution of ATM system for the next 25 years, which would also need to be coordinated and also converged into a concept state, including such topics as unmanned aviation and advanced air mobility. So, I've been going too fast. I think I'm too excited to show you about TBO, but I haven't finished yet the GETMO. So ICAO has been requested to update this foundational document. This update would reaffirm the core principles of the current GETMO, while adding to the scope and the principles reflecting operational visions of new airspace users. From now on, Let me go into a bit more detail into each enabling concept that was developed after the GetMOOC was born, their interrelationships, and ongoing work of ICAO. First, trajectory-based operations. Again, all of you, I believe, have heard of the term TBO at least once in the last 5 years. However, when it comes to you, what the TBO looks like may be very different. So today, I'd like to take an opportunity at least to ensure the people in this room could have one common view of TBO. I'm not sure if that saying exists in English as well. In Korean, there's clear saying, pictures work way better than the words. I guess nowadays videos work even better than the picture. So let me play the short video.
A little knowledge goes a long way, especially when that knowledge guides our decisions along the journey. That's the essence of the trajectory-based operations concept. In short, TBO is an air traffic management concept that enhances strategic planning under changing conditions, providing the information and capabilities to help expedite aircraft movement between origin and destination airports. TBO will shift from a voice-based set of exchanges between participants to an environment primarily involving data exchange between interoperable systems. See how TBO is shifting the decision-making paradigm, moving from a tactical approach to a more strategic one. Currently, tactical decisions are taken because some information is only available at the moment. These add up, and operators pay the price by loading more fuel. If we had greater access to the information, we could, and we would, make more strategic decisions ahead of time, instead of reactive course corrections. But by continuing to follow a tactical paradigm, we waste time and fuel. Imagine having access to the information you need, when you need it, and having it tailored to improve decision-making for your flight. Data exchange technology has caught up with this vision, and now we have the capabilities to make it happen. Through improved strategic planning and management of traffic flows, TBO will reduce reactive decision-making. This will increase predictability and efficiency and optimize the ATM system. Aircraft trajectory is the core tenet of TBO. Defined in 4 dimensions, latitude, longitude, altitude, and time. The trajectory represents a common reference for where an aircraft is expected to be and when at key points along its route. The trajectory is defined prior to departure, updated in response to changing conditions, and shared between stakeholder systems. Here are the 3 key TBO features. First, sharing trajectory information and providing access to the best data, eventually leading to a more accurate view of the trajectory for participants. Second, managing trajectory information using collaborative decision-making. And third, using the shared trajectory as a common plan for the flight by providing a common intent to be achieved during flight execution. This shift towards data exchange, allowing the sharing, managing, and use of 4D trajectories. A range of enablers help support TBO. Time-based management helps manage traffic flows and trajectories by scheduling and metering aircraft to better manage congestion. Performance-based navigation enables aircraft to more accurately navigate along their trajectories. When combined with decision support tools, predictability and compliance to schedules are improved. TBO is the use and exchange of better information across systems, capabilities, processes, and people, working together to improve the performance of air transportation. TBO builds on these enablers, helping support the operation shift to manage and use the trajectory as the representation of flight intent. And that brings us to the next exciting phase of TBO.
I hope you enjoyed the video. I think it lights up a little bit this afternoon's session. I'll give you a quiz. Do you remember what are those 3 key features of the TBO? Yes? Time-based. Bravo. Sharing the trajectory, managing the trajectory, using the trajectory. Keep those 3 key features because I'm going to continue to use them when I explain the next set of the concepts, okay? So the trajectory-based operations, the essence of it is to optimize the flight trajectory throughout the phases of flight, starting with the pre-departure agreement on the trajectory. Once the agreement is reached, the agreed trajectory is defined with 3-dimension position and corresponding time information with constraints and tolerances around it. The aircraft then follows the agreed trajectory. The ATM service providers will continue to monitor and control trajectory to be hazard-free to meet the time objectives. However, when there is a need to revise, update the trajectory due to conflict or weather or any other significant change, the stakeholders modify trajectories through proposing the change to the agreed trajectory, predicting the trajectory will meet the constraints, evaluating the impact, and agreeing on the resolution. This process is made through a collaborative decision-making with sharing synchronized information amongst participants, ground-ground, air-ground, which will be enabled by FFIs, SWIM, connected aircraft, concept, and services. So now I'm leading to the next set of enabling concepts. Before I go on to further, yes, it is easier through the video, through the presentations, but again, there was a request from the global community to refine the current concept document, which is like about 70-page document, and also update the GAMP to provide more clarity to the relations between the ASBU threads and elements, how those are actually contributing to the TBO. So this is the current version of the GAMP that shows the description of the evolutionary path of the TBO and also the relationships with the other elements. But this is going through a major update for further improvement. And also there will be a guidance to help the ANSPs and operators to be able to plan and implement TBO enablers, and also for the IQ expert groups to make the necessary proposals for amendment for the global procedures and standards. So what are the key building blocks then of the TBO? Starting with the FFIs and SWIM and connected aircraft will be the next set of the slides. Start with the FFIs. It is flight and flow information for a collaborative environment. Today, as you can imagine, this is about the flight information. How is flight information shared today? Through the flight plan. The challenges and the limitations that we live with the current flight planning mechanism is, depending on who you talk to, the version of the flight plan that they have is different. The one stored in the flight management system, the one that is filed by paper from the flight dispatcher, and the departing aerodrome and the next ATS provider. So inconsistent duplicate flight plans, which causes the confusion amongst stakeholders. Sometimes incorrect information leads to the safety risks. And also the intention of a flight only supplied to the ATM service provider very last minute. So there's no room for coordination or negotiation to make that a flight plan even more optimum for both operators and the air service provider. And also, as all of you know, the flight plan sharing mechanism today is based on 70-year-old technology. We still have to limit ourselves because there's a characteristics limit. We can only use a certain number of characters. Can you believe? We share pictures, we share videos, and long emails instantly. However, we're still basing on the 70-year-old technology. See, like picture shows that just prevent us moving forward. So what does FFIs do? It allows you to uniquely identify flights because it will give you an additional information called the Goofy. Sounds weird. There wasn't some attempt from our Air Navigation Commission to make the term better. But it is what it is, a globally unique flight identifier. And also flight plan will have versions. And through the additional services, it will allow operators and the service providers to negotiate and coordinate to make the flight plan better. And as all of you know, the SWIM-based services uses the latest technology, underlying technologies, that is not 70 years old. The technology that we use today, day to day, but it's more aviation focused. So this FFI's concept has turned into 6 set of services, but I'm not going into detail in this. The concept is not anymore a concept. It has been defined as a 6 set of services. These first 2, filing service, flight data request service, is soon to replace your current flight planning. And all these other services, which are introduced as an optional service, will allow you to be able to collaboratively develop and update your flight plan before departure, after departure. So, what happened to these services? Now it's showing up in the ICAO document in annexes, not only one annex, all annexes, provisions that involve flight plan and flight planning. So proposals for amendment to enable the voluntary use of FFI services, but in a standardized manner, are available currently going through a state consultation. With the responses and feedback, and the provisions will be refined, we're envisioning for applicability date of November 2024. We're not only giving you requirements and procedures, we're also giving you a very detailed implementation guidance. The concept that was developed 10 years ago is refined as a volume 1, and it also provides detailed implementation guidance. Now, I mentioned earlier, the FFI services will be introduced as a voluntary services at the beginning. Like when the PBN was introduced, like when the RVSM was introduced. But we could go different approaches as the benefit could drive a wider deployment of these services. However, this time, we may take a slightly different road. Why? The longer this mixed mode operation, the coexistence of the legacy system and the new system or new procedures will negate, envision, or delay the envisioned benefits that we expect for the ATM system. So there will be a very strong campaign down the road to collect the views from the stakeholders and also a system to consider and planning to phase out the legacy flight planning system. This is going to be a collaborative process from ICAO and the regional planning forums and also the states. Currently, this is contained as a guidance in the draft document 9965 second edition, and there will be more opportunities that we can share with you about the details about this strategy. So, remember the last line of the FFIs, the new technology, not the 70-year-old one, that is SWIM. SWIM will offer the scalable and interoperable information exchange capabilities. So to enable the effective implementation of FFIs, we also needed a set of provisions and guidance for implementation and deployment of SWIM. So there is ICAO provisions that describes the requirement for all layers of SWIM, technical infrastructure, the use of information exchange models, and the way you exchange information. And also, We heard about the cyber threat, cyber resilience, cyber security. Since our aviation system is interconnected, digitized, there is a higher threat for cyber threat. And we are fully aware, and therefore we're introducing some preventive measures that allow this digitization and also deployment of these new concepts and procedures in a secure manner. Again, there is a set of provisions that have been circulated to states for comments. If everything goes well, with your feedback, refined provisions will become applicable November 2024. Now, I talk about sharing information and a coordination, ground, and air-ground. How does it happen with the air-ground? Now it comes with the connected aircraft. One of the elements of the TBO is strongly based on the data exchange and also data communication. Remember the very detailed trajectory that has three-dimension information, position information with the time, and tolerances around. This is impossible to convey in voice. It is a prerequisite to have a data communication ready. Today, there is some level of connectivity between the aircraft and also ground users through applications like electronic flight bag and also the commercial links. However, in the future, we will have various additional links that will allow more connectivity between the ground users and flight deck. And through this exchange of information between the ground stakeholders and the flight deck, this additional real-time information, I think that some of this concept is already realized, as you witnessed today by the presentation from our Captain Bae from Korean Air. Remember the turbulence tasks? That's exactly part of this connected aircraft concept. They take the information from the airplane and share it on the ground partners that they can use for whichever purposes they have. So ongoing and future work of ICAO to ensure the relevant provisions and guidance for well-performing data communication, we are improving the existing provisions and guidance material. And also, we're develop and refine this connected aircraft concept. However, to all the components of the connected aircraft concept to be realized, there is a lot more work to be done. For example, will those new links that allows us higher connectivity between ground and air, not the traditional aviation communication link, will they performance parameters and the specifications will be the same? What about the certification of those links? What about the operational procedures of all these additional links and additional information that will be available? So there are a lot more to be done. However, there is a vision. With all these innovations and the technological advancements, safety will still continue to remain as a priority. However, the way that we treat, the way that we manage safety will need to evolve because we cannot really manage safety in a silo anymore. So as mentioned by our Mr. Kelleher, President of the Commission, there is a new streams of work in the safety management to consider this integrated safety management approach. I think that leads to my last part of the presentation. I've told you a lot of very high ambitions, but those ambitions can be achieved if we make bigger effort. But opportunities are just ahead of us. Why? We have these beautiful technologies, innovations that are there for helping us to move forward. So with all that, we can transform. That's the last part of the little butterfly. Transform air traffic management system into the next level. Before I conclude, again, all these concepts and the actual planned implementations, you can come and share your views. First, about how we can further improve our concepts, how we can deploy these concepts in a safe and efficient manner, come and tell us at the August event in Montreal. And there's another event. Even if we're looking into all these futures, if you do not have a fundamentals, let's say TBO, wonderful, beautiful concept, but if you cannot put the aircraft like minimum separation, if you still separate aircraft like 80 nautical miles or 50 nautical miles with the radar, TBO will never be realized. So there are fundamentals that you need to have today. So come and tell us what your challenges are, and we'll tell you how to solve those in this October event in Singapore. I'm not going to go through the actual subjects that will be dealt in the August and October event, but it is here for your information. And if you click the title of the event, it leads you to the event website where you can find more information. So again, thank you very much. I try to cover a lot of subject in a very limited time. Sorry for going a little bit beyond. Thank you for your attention. I hope my presentation was informative and interesting. Thank you.
All right, yes, the microphone is awake now. I hope everyone else is as well. The afternoon session is always a bit harder, but the session was on technology and innovations, new things that are coming. And so we've talked about new aircraft, new types of operations, using new aircraft to conduct NAVAID inspections. So being part of the aviation system. We have new information that is being obtained and shared to air traffic controllers from the digital towers. New ways of gathering information, sharing information, new information that is being fed into the system and shared amongst all the various stakeholders. So all of these things that are bringing about enhancements to aviation safety. And with that, I want to open the floor. We have a couple minutes, not many, but we could take a question or two if there. Yes, we do have the questions. They've already been submitted. Thank you. So, with our first question, Jun-Sup Lee, may we have more information about the RPA and is it integrated to the FDM? Oh wait, no, that was from the earlier session. Because this is about the turbulence events and that RPA. We're a little confused here.
We have the operating manual about the DIVA system. Refer to that the manuals. We are not allowed to activate the aircraft, the drones, the RPA, more than 5 meters per sec, the wind speed. So it's almost the same as the aircraft operate procedures. So before we start our inspections, we need to check NOTAMs and weathers and safe conditions, things like that. So, and we connect with the FD, which is the flight computer of the drones. So we receive the drone's flight data from the drones, gyro, and computers, things like that. Thank you. Is that right answer?
I would say that you know much more about it than others of us, so We will take it as the correct answer. Thank you. Do we have any other questions from anybody in the audience? Oh, yes, there is somebody at the back.
Hello. I want to ask John Dongmin a question in Korea. 안녕하십니까? 저는 한서대학교 항공교통관제
I'm from Hanseol University and I am studying aviation ATC. And so you're talking about a target of creating a digital tower that is not in operation currently for the remote tower. What is the difference? I think that there will be a difference in the reliability felt by the public. If the public does not feel that the digital tower is reliable, then it cannot be in operation. So, for the Incheon Airport Authority, how will you be increasing the trust into this digital tower from the public?
There are many airports operating the digital remote tower already. However, as you say, there are no airports operating digital tower in Korea yet. So, because of this reason, we are implement digital tower inside the physical tower in advance. So the master plan about Terminal 3 is in progress, and Terminal 3 will be constructed after 2031. So we have time. So first, we will operate the digital tower for about 6-7 years. Then we can check the validation enough. So yeah, so because of this reason, we are doing this project, Smart Integrated Control Platform, and this experience, based on this experience, we will consider about remote tower after.
All right, we're going to stop now because we actually have just a very, very short break before the next session is going to start. So how about we give the speakers all a big thank you.
Thank you very much, the speakers as well as the moderator for joining us for the second session. I know it was indeed a heated discussion and you will need time to digest all that we have discussed.